I just want to bring your attention regarding the spreadsheets that you're going to be turning in for the equilibrium constant lab. And I wish you guys were able to do this, but I just want to point out a few things to you regarding your uh, your Excel spreadsheets. You'll find this in the Dropbox, and we also have them color coded as to what you need to do. And also, if you look in the Blackboard, you will see the formulas that you will need for the different parts here. I just try to make things a little bit easier for all of you, and make sure too that you put in your graph over here as well. Also, the one thing that I saw some of you were missing was down here in part C. So this is for parts A and B, and then what should have been part C for the lab is right down here that I saw that some of you had forgotten to do here. So this is for parts A and B of the lab, and then when you watch the video, that is for this part here, part C. And I want to go over a little bit of more detail as to what's going on with this and how I want you to go about doing the information here. Just real briefly though, with the observations, this is what do you see taking place in the video. The explanation is why is it doing what it's doing. So basically, you're just putting down here, did it change colors? Did it get brighter? Did it get darker? And then over here, you're explaining what's going on and whether or not the reaction had shifted left towards the reactants or if it had shifted to the right for the products. But this is a part that I saw some of you must have overlooked this tab down here at the bottom for part C. So if you have already submitted your lab, make sure that you do this and resubmit it before the deadline. All right, so I'm going to spend a little bit of time going over this information here. All right, class. One of the first things I want to draw your attention to, and this is one of the papers in your Dropbox, or I'm sorry, in your Blackboard, and this is just a flow chart with the Chatellier's principles here. So the way that you go about reading this is that the dark arrow is a stress that you are adding to the system. So in other words, if I increase the concentration of A, so if I increase A here, the reaction is going to, and if you look at the arrows over here, this will indicate what direction is the reaction going. So up here at the top, this is a hypothetical reaction. And say you have A and two parts of B produces C and D and also generates heat. So this is an exothermic process here. And if this is in equilibrium, as indicated by the two equal arrows in opposite direction here. So if I increase the amount of A that I have over here, then what's going to happen here is the reaction is going to shift to the right, and in order to compensate here is that these values over here, C and D, will have to increase in order to maintain a constant value. Also, so if you look over here, if I increase D, so if I increase D over here, the reaction is going to shift to the left, and what's going to happen are my reactants are going to be increasing. If I decrease B, so if I decrease this value here, the reaction will shift to the left, and as a result, in order to maintain the equilibrium, is C and D will have to decrease. If I decrease C, the reaction will shift to the right towards the product side, and my reactants A and B will have to decrease. Now we're not doing anything with pressure. You can see that here. So we're not doing anything with pressure. But one of the other parts also was having to do with temperature. We didn't do anything with catalyst, so we ignored this part down here. And one of the other procedures that was also done was we also added heat to the system. Okay, as you can see at these two. Now we didn't do decreasing the temperature, but we did increase the temperature of the two. And so if the reaction is an exothermic process, then one thing we should see here is the reaction should shift to the left. If you add heat to an endothermic process, the reaction will shift to the right. Okay, as indicated with the larger arrows over here. Okay, so let's take a look at the reaction that was taking place. And you're taking the ferric ion and also the thiocyanate, and in doing so, in addition, when you first mix these two, you had the iron solution, you had the thiocyanate solution, and you didn't have any products at all, so everything would shift to the right. And in doing so, it ends up producing this ion of iron thiocyanate, which has a -2 charge to it. Okay, so initially that was the reaction that had taken place here. So this is the main reaction occurring. Now, once this is being produced here, there is going to be an equilibrium, and eventually the reaction will stabilize by also going this way. So this is a dynamic process that's going on. That means you have to picture a whole bunch of these, and as soon as two of these come together over here to make this, some of the thiocyanate is also splitting apart to come back to the reactants. So as soon as two come together, it goes over here, and as soon as it does so, two are separating to come over here. Okay, so you have to picture, billions and billions of these things here are constantly going back and forth between these 2 points here. Okay, so this is not a static system here. This is a cyclic system. This is a very dynamic system which is going on. All right, so what we're looking at is what type of process takes place whenever you add some sort of stress to this system. So, the next thing I want to point out to you here is that the iron thiocyanate, or the iron thiocyanate here is produced by the iron and also by the thiocyanate. And by increasing, if you want to, there's two ways we can cause a stress to the system, is by increasing the amount of iron, and that's done with the ferric nitrate. Okay, this has a +3, this has a -1 charge. Or another way we can also increase the amount of thiocyanate is by adding more of the potassium thiocyanate. Potassium has a +1, thiocyanate here has a -1. So this iron here is contributing more iron over here. The thiocyanate over here is contributing to the thiocyanate that's over here. So that's how we can go about increasing, either increasing the amount of iron or increasing the amount of thiocyanate, by adding the iron nitrate or the potassium thiocyanate. The nitrate and the potassium, they remain aqueous, they don't participate in this process here. So we can almost eliminate those things here, but I'm not going to eliminate that. So this is what's contributing the iron, this is what's contributing the potassium or the thiocyanate. There's also a way to decrease your amount of reactants. So in order to decrease it, one thing we can do here, if I want to decrease the amount of iron, I can add potassium hydrogen phosphate. Okay, potassium has a +1, hydrogen phosphate has a -2 charge, and this part right here will decrease the amount of iron. Likewise, too, if I want to decrease the amount of thiocyanate, what I can do here is by adding the silver nitrate. Silver 1 nitrate. Silver's +1, nitrate's -1. And what silver does is it bonds with the thiocyanate. It produces a precipitant, and it will decrease the amount of thiocyanate. Same thing here with hydrogen phosphate. It will bond with the with the iron here making ferric hydrogen phosphate. So when this happens, this will bond with the iron, and in doing so, it will produce ferric hydrogen phosphate. Oops. Hydrogen phosphate. And to balance it out, 3 and 2. So when hydrogen phosphate is in the presence of ferric, or iron 3, it produces iron 3 hydrogen phosphate, which precipitates out, produces a solid. Same thing with silver. Silver will bond with the thiocyanate, and it makes silver 1 thiocyanate. And this will also precipitate out. So if you want to increase the amount of iron, you add more ferric nitrate. If you want to increase the amount of thiocyanate, we add potassium thiocyanate. If you want to decrease the amount of iron, we add potassium hydrogen phosphate, which basically pulls out, the hydrogen phosphate pulls out the iron. If I want to decrease the amount of thiocyanate, I can add silver nitrate, and the silver will bond to the thiocyanate, making silver thiocyanate. So basically, it's like ripping these things out of place here. So that goes back to this over here. So we're able to manipulate the reactant side. So if I can either increase, A or B here, or I can also decrease the amount of A or B as well by introducing or removing more of the A or B, or decreasing the amount of A and B. So hopefully that makes sense here. So let me put this and kind of give you a little bit more of a somewhat of a graphical means of what's going on. All right, so you get the picture. There's a large amount of iron. I'm just going to make a few of the irons. And some thiocyanates. And also making the iron 3 thiocyanate. Okay. So again, this is in equilibrium. All right, one other thing it's also important to realize is the colors that are being produced here. So what's nice about this reaction is that there is a very visual means of telling what is going on. And so a few things regarding this particular reaction here is that the iron, I'm going to write it up here, the iron up here is basically colorless, but technically it's a slight yellow color. The thiocyanate is colorless, looks like water. The iron thiocyanate, this is a very deep red brown, almost like a blood color to it, or like a rusty reddish brown color to it. So if it becomes lighter in color, then the reaction is shifting to the left. If it becomes darker in color, you can visually see that it's shifting towards the right. So you can tell what direction the reaction is shifting here, left or right, towards the, left towards the reactant side, to the right towards the product side, simply based upon what's happening visually here. Now the other part of it too is be able to explain what's going on. Using this as an example here, with your very first one here with the control, you added some of the iron nitrate and the potassium thiocyanate, and initially you had none of the potassium thiocyanate here. So in other words, you're adding the iron and you're adding the thiocyanate, but by adding these two solutions together here, the reaction will shift to the right, producing the iron thiocyanate. So in the very first part of it with the control, you are, with your observation here, one thing you put down here is like what were the initial colors, and then what was the end result. So in other words, you had the iron, which is kind of a yellowish orange color to it, the thiocyanate, which is clear, but you mix the two together, it turns kind of almost like a blood red color to it, or a rusty brown color to it. Okay, so over here you can say that the iron and the thiocyanate are joining together to make the iron 3 thiocyanate. So the reaction will shift towards the product. Then in the very first one, you're adding the silver nitrate. Now remember, silver nitrate has the tendency of decreasing the amount of thiocyanate. So what we're doing here is, by adding silver nitrate, we're decreasing the amount of thiocyanate which is available. In order to maintain equilibrium, some of the iron thiocyanate over here will need to split apart and move over towards the reactant side. So the reaction will shift from the right, because it was initially red, and the fact that it ended up turning pale, basically either eliminated or nearly eliminated all the thiocyanates, so the reaction to compensate will shift to the left. So with your observation, like in the very first one, the numbers on the video don't correspond to the numbers over here on this side right here. Just pay attention to what's happening with the reactions here. Okay, so technically I believe it's number 2 on the video, so that doesn't correspond with one over here, or with this 2 down here. So when you add the silver nitrate, it was initially, so your observation, it was red, but by adding silver nitrate, all of a sudden the solution turned pale, or basically turned like a white, milky white color to it. So you write down what your observation was over here. The explanation is that the silver nitrate is eliminating the thiocyanate. So in order to compensate, this is what's causing it to turn red over here. This stuff is splitting apart and coming over to this side here. So it went from being a red to, the reason why it's pale with the colors up here is because basically you got rid of most of these over here. So the reaction had to shift towards the left, towards the reactant side, in order to compensate. So the next thing was, you're adding the iron nitrate. Now, you write down your observations you see taking place over here. So, what color did it turn? Did it turn deep red, or did it turn pale, or did it remain kind of a pale? It may have turned maybe slightly yellow or something like that here, but did it return back towards a deep red color? If it turned a deep red color, you're making this. If it's pale, you're making these over here. So by adding the iron nitrate, if it was pale, so look at this. The very first step, you took the silver nitrate, you eliminated this. Okay, so the reaction shifted to the left. Then you're increasing the amount of iron over on the other side. So let me do it this way here. If I add more iron over here, but there's no thiocyanate, can the reaction still shift to the right, or is it going to remain as it is, shifted towards the left? So write down what color do you see happening over here. So again, if it's dark red, it shifts to the right. If it's pale, it might be slightly off here or something like that, it's going to the left, or towards the reactant side. So write down what you see taking place over here. and then explain why did it do what it was doing over here. Okay. Now for some of these, so basically the color that you see taking place is telling you, is it shifting towards the product side, or is it shifting towards the reactive side? And then look at, by adding either these or these down here, what is it doing? So you're increasing or decreasing the amount of these different ions, and why is it doing what it's doing? Okay, so hopefully that will help clarify what you're doing here. The one thing I also want to draw your attention to, the very last one, when you're dealing with heat, compare the colors of the control to the one that was heated up for 2 minutes, and then explain, was this process, did the reaction shift towards the left, or did it shift to the right? Now, it might not completely shift left or right, but you should be able to tell when it turns lighter or darker, if it's going to be, if it's shifting a little bit more this way, or if it's shifting a little bit more towards this direction. And if you go back to, let me find the paper here. If you go back to this, because you're adding heat to the reaction, I want you to be able to tell me, was this reaction an exothermic process, or was this an endothermic process? Hopefully that makes sense. If you have any questions, make sure you can email me. Just make sure that you get this turned in on time. Also, I'm going to be posting the next assignment, which is a titration of buffered solution. It's going to be a virtual lab. I miss you guys. I really wish that we were back in the classroom, and I wish it was under better circumstances, but hopefully all of you are staying safe and doing what you need to do to keep yourself healthy and keep those around you also safe and healthy as well. I wish you all the best, and I will talk to you guys later, hopefully soon. All right, bye-bye.